Hey 5th grade, this is Miss Davis here, and this video is going to talk about multiplying decimals a little bit more. This is Friday of spring break, so today is March the 13th when I'm making this video. I know some of us got different places with multiplying decimals before break. Some of us didn't even talk about multiplying decimals before break. My class specifically talked about multiplying whole numbers and decimals, so that's where we're going to start with a quick review problem, and then we're going to go into multiplying two decimal numbers together. So the first problem that we are going to start with is right here, and it says Randy buys 6 bags of salt and vinegar potato chips. If one bag cost $2.68, how much does Randy spend? So like we talked about before break, there's two ways that you can do this. You can use standard algorithm or you can use your box method. What I prefer to do standard algorithm, but I'm going to show you both ways so you have the option to do either one. Regardless of the way that you choose to do it, the first thing that you have to do is that you have to kick out those decimals. So if I have $2.68 times 6, I can remind you guys that place value does not matter when you line up this multiplication problem. I'm trying to figure out how much 6 bags of salt and vinegar potato chips cost if one costs $2.68. So that's why I'm having to multiply in this problem. So as I look at this, I'm going to try and make $2.68 a whole number here. And I'm going to bring my computer a little bit closer just so you guys can follow along here. So I need to kick that decimal point out 2 times in order to make it a whole number. So I'm going to move it out once, twice. And as I showed my class before break, I just like to note how many times I kicked my decimal out over here in what I like to call a little bubble. So I'm going to show that I moved my decimal place out 2 times. Now, I'm going to multiply this number as if it were like this. 268 times 6. Okay? So, I'm going to work back over here on my blue problem. So, 6 times 8 I know is 48. I'm going to put my 8 down, carry my 4 up. 6 times 6 I know is 36. 36 plus 4, 37, 38, 39, 40. I'm going to put my 0 down and carry my 4 up to my 2. 6 times 2 is 12. 12 plus 4, 13, 14, 15, 16. That's 16. Because I don't have another digit over here, I put both digits down here. So I have 16. Now, I know that I did not pay, or Randy did not pay, $1,608 for a bag of chips. I would never buy chips if that was the case. So I know that I have to add my decimal back in 2 times. So I'm going to do that with my blue and show you what that looks like. When I start, I'm going to start from the 8 all the way over here and move it back in twice. Once, twice. Therefore, my decimal is going to go back in between the 6 and the 0. And therefore, Randy spent $16.08 on 6 bags of salt and vinegar potato chips. Now, as we go to talk about decimal by decimal, the first thing that we are going to open up with is multiplying tenths by tenths. If you look here, the first problem I have is 6 tenths times 8 tenths. And I'm going to show you this modeling first. And I'm going to use red and I'm going to use blue in order to model this for you. So I am going to represent 6 tenths in red. I'm just going to underline it in red. That way I know that that's the color that it's shaded in. And I'm going to start shading in 6 tenths. Now, I know each of these sticks going up and down here represents tenths. So therefore, I'm going to have to shade in 6 of those. So take a look at this. okay? Make sure that I've shaded in 6/10. I'm going to do that just a little bit darker so that way you guys can see. I apologize if you hear some dogs barking in the background. There you go. Now, I've shaded in those 6/10 vertically, going up and down. I need to do 8/10 this time, and 8/10 I'm going to do in blue. So I'm going to underline it in blue, but I'm also going to do those horizontally. So I'm going to focus on going across when I shade in 8/10. And again, thankfully this is not for an art show or anything else. I'm just going to lightly shade those in. Now, when I'm using a model on this problem, I'm going to be able to find my answer in the overlapping piece. So this should kind of ring a bell as far as when we talked about multiplying fraction by fractions using a model. It's where those two colors overlap. In this case, I know that red and blue make purple. So in this case, it's going to be where I see my purple or where I see both red and orange. So I'm going to go through and need to count how many boxes have both red and blue in them. So I'm going to move this up just a little bit so you guys can see. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 45, 46, 47, 48. So I have 48 boxes that are shaded in both blue and red. So I know that my answer is going to be not just 48, because remember, this is a hundreds grid. This is a decimal hundreds grid. So each of those boxes now represent hundredths, each individual box. So my answer to this problem is going to be 48 hundredths. And I can show you using the standard algorithm down here how to get that. So again, here I have my problem laid out, and I've got to kick my decimals out first, so I'm going to do that in green. And this time I had 2 decimals to kick out. So you'll notice that I moved this one once and I moved this one once. That's a total of 2 times. So I had to kick my decimal out 2 times, one on the top number and one on the bottom number. Then I'm going to multiply as if this is 6 and 8. So if I move that problem over here, you know that 6 times 8 is 48, I hope. But my answer on this problem isn't just 48. I'm going to have to move that decimal back in twice. I'm going to start out here on the other side of the 8, and I'm going to move it back in once, twice. So therefore, I get the answer 48 hundredths. So hopefully you're kind of seeing a pattern as far as multiplication facts. 6 times 8, well, 6/10 times 8/10 is 48 hundredths. So let's look at the next one. The next one is 4/10 times 3 hundredths. Or I'm sorry, 4/10 times 3/10. Sorry, I was looking at that wrong. And again, I've got to model it first. So I'm going to look at how to shade in this model for 4/10 times 3/10. I'm going to start with my red again, and I'm going to start there with 4/10. So I'm going to shade in 4/10 of my model. There's 4/10 of my model shaded in. With my blue, I'm going to do my 3/10, and my 3/10 is going to go horizontal. So I'm going to shade it in this way. And then I've got to look and see how many pieces are overlapping. What's overlapping in blue and red, or what makes that purple color. So if I look there, I'm going to start here and count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, it's important to realize the answer is not 12. This is a decimal board. It's a hundreds grid. So each one of those blocks are representing hundredths. So my answer to this problem is going to be 12 hundredths. And I can show the same thing down here in the algorithm with 4 tenths times 3 tenths. Again, I'm going to use my green to kick that decimal out first. Move it out once, move it out once. That's a total of 2 times, one on the top, one on the bottom. So then I can multiply it just as 4 times 3. And I know, and everyone else should know, that 4 times 3 is 12. So I get 12. I've got to take my green. I can't forget to move that decimal place back in 2 times. 1, 2. So therefore, my answer there is 12 hundredths. Please make sure that you try and take notes throughout these videos, and that way you can ask for help and come back if you have any other questions from your teacher.